So now let's look at the new VRay lens effects in VRay 2.0. I have a scene here with a few reflective objects, and I have a really bright light source here, and then I have a plain light over to the right, which will produce some nice reflections on the reflective objects, and I also have some colored lights, VRay plain lights on the top here. So this is the camera view, and this is the rendered image. And if you look at the edge of the VRay light over here, you can see you have some real anti-aliasing problems, and this is because of the very bright value of these pixels. It's really hard for VRay to anti-alias this edge properly. And you can also see the same effect in a few of the reflections on the objects over here. Now, in a real-world camera, if you took a picture with bright light sources or bright reflections, what you'd normally get is some sort of bloom and glare on around these areas, where the color would bleed from this really bright and into the darker colors surrounding it. And with the VRay lens effects in VRay 2.0, we can now simulate these things in VRay. So I've added the VRay lens effect to the scene, and I've set it to interactive so that we can see the updates happening in real time, or almost real time. I'll turn first I'll turn bloom on, and instantly you can see that this bloom now removes all the anti-aliasing problems that we had in this image. Now, bloom has a few different parameters that you can adjust. The first one is, of course, on and off. Then we have the fill edges option, and if you look at this area around the edge of the frame, if I turn this off, you can see it goes a bit dark here because there's no more bright image data to use in the calculation. So if you use fill edges, it will actually repeat the edge pixels and provide a uniform effect over the entire frame. Next, you have the mode. You can choose to modify the rendered image only, or you can modify the rendered image and get a render element, which means you get the bloom effect as a separate render element that you can use in compositing. Or you can choose to just create the render element and not modify the original rendering. And you can see over here, when you're using the VRay lens effects, you get all these extra render elements. This is just the bloom, and it's not mixed with the original rendering, which is this one. This can be useful if you want to adjust this effect in compositing instead of baking it into your render straight away. So let's look at the weight parameter next. This determines how much of the bloom and how much of the original image will be used. So if I set this to 0, this is the original rendered image, and if I set it to 100, you get only the bloom effect and you lose a lot of the details. So you want to play with this and find a weight value that gives you the look you're after. Normally I like to use something around the default value of 50. Next you have the size, which is the size of the bloom. Basically it's like a blur radius. If you look at the bloom itself, it's easier to see exactly how this works. And then the shape determines how much, or the fall of the blur. So if you increase this, you retain more of the original shape, and then you can decrease it to get a really soft blur. So if you look at the composite now, this is almost like you have a filter in front of the lens. So next, let's look at the glare, and this is the glare that's happening inside the lens. And there are three different options here. You can get it from an image from the render camera if you're using a VRay physical camera, or you can actually set, if you're rendering with a normal standard camera, you can set the camera parameters down here. Fill edges is the same as in the bloom, and weight is also the same as in the bloom effect, and size controls the size of the glare. Now there are a couple of other really interesting options here in the bloom. You can turn on diffraction, and if you look at this, especially around the edge of this light source, I'll turn it back off, and you can see this uniform, almost monochrome color. But when I turn on diffraction, the rays are separated a bit into the spectrum, so they create this nice diffraction effect, which has more of a colorful glare. And then you can use an obstacle image for the glare as well, and this will affect the diffraction. Think of this as light passing through an obstacle, like a slit or another shape, and what will happen to the light waves is they will bend through this obstacle and create interesting patterns. Now for this sample I have an image of these three black strips, and that produces this result. You can experiment with these images. I'm just using black and white ping files that I just created in Photoshop, and this can be used to create some really interesting diffraction effects and very stylized looks. Of course, by varying the size, you also vary the look of the diffraction. There's some other examples here. If you want to simulate the effect of looking through your eyelashes, like when you're squinting, you can create an image that looks a lot of vertical lines. If you have more parallel vertical lines, you get a more separated effect. And then you can go to the real extreme, like I have a file here with just 1 pixel vertical lines, and this really splits the diffraction rays into several sub images. Also have some a fine grid here which will split it horizontally and vertically, and this can of course be used to create some very stylized effects. I have a hexagon, you get these different rays, and horizontal lines, you get it, the diffraction happens vertically. So you can just go in to Photoshop and just experiment with creating maps. Takes just a few seconds to brush something out and apply it and see what it looks like. Next I'll be looking at the from image option in the VRay lens effects, and I'll add an HDR file with a big halo. So now instead of using the camera settings, it's actually getting the whole glare effect from this bitmap. And the way I created this bitmap was using the VRay lens effects filter generator. And this is included in VRay 2.0, and you'll find it under the Start menu in Chaos Group VRay, and then in the Tools submenu. And this is a really quick and easy editor to use. It has 4 different tabs that let you vary the different the corona flare line pattern and the special flare line pattern. You can create various different looks. You have a halo that you can play with the 2 radiuses of, and the diametric setting determines if it's mirrored across the center point. If you turn off the diametric, then you get some sort of asymmetric flare line pattern. With diametric, it's more symmetrical. Every line will pass through the center and extend to the other side. So you set up the 4 different tabs up here, the 4 different elements of the glare filter, and then down here is a mixer where you can add how much of the patterns, these 2 patterns, pattern 1, pattern 2, you choose the amount they should contribute to the filter, and then the amount the halo should contribute as well. So you can turn the halo up, and then you can choose whether you should apply the flare pattern and the special flare pattern. You can also change the aspect ratio of this if you want asymmetrical glare filters. Then you can save these as presets, which are actually just text files, and then when you're done creating this, you can export to an HDR file. I'll just call this sample, and then I can go back into Max, and this is the flare filter pattern that we just generated. So the VRay lens effects is a really good way of adding that photographic imperfection which photographers through the times have tried to avoid, but which add that extra bit of realism to your renderings. For this section, I'll be talking about the new shade maps in the VRay stereoscopic helper and how you can use the shade map to speed up your stereoscopic rendering. Now, as a sample scene, I have a moving object which will produce a motion blur, and I have 2 other objects, and I have a VRay camera which is set to focus to the middle object, this one. So let me just render this first so you can see what it looks like. So you can see the motion blur on the horse in the back and the depth of field effect on the horse in the front. And this took 24 seconds to render, So now let's go and render a stereoscopic version of this. I have a stereoscopic helper in my scene. You can add this by going to Create tab, Helpers, and VRay Stereoscopic. And I'll enable this and render again. I'll pause this while rendering. Okay, so the rendering finished, and you can now see that the stereoscopic image took almost twice as long to render. VRay is able to reuse some of the irradiance map and light cache data from the scene, but the ray tracing and the motion blur and everything has to be rendered twice. So with the new shade maps and the VRay stereoscopic helper you can find here, there's a new way to actually store a lot of the data in the rendered frame and then reuse that for both the left and right image. And the way that you do this is you select render shade map, and then you basically put in a file name and you render. And you'll see that this rendering is now done without any motion blur, without any depth of field, and only for the center camera, not the left-right cameras. So now we've rendered this and it's automatically saved to this file. So what we can do now is we can select use shade map instead and re-render our image. And the way this works is VRay now calculates the irradiance map, but it actually only needs to recalculate a few areas where it doesn't have any data. And you can see our stereoscopic image now took only 16 seconds to render, which is a very big speed up compared to having to render the 24-second render twice, one for each eye. So what happens is the center image is actually then projected back onto these two views, and only the parts that are occluded in each view need to be re-rendered. This is a really great way to speed up stereoscopic workflow, but this can actually also be used for single frame rendering. And the trick then is to actually select only one stereoscopic view for rendering, and then you can set the eye distance to 0. So if you render this now, this rendered in 8 seconds because it used the stored data. And the beauty of this method is that this now lets you actually go in and start experimenting with things like motion blur or depth of field or the other camera settings without having to re-render the shade map. So I'll select the camera, and currently my f-stop is at 1.4 and my shutter speed is at 100. So if I want more motion blur and less depth of field, I'll go in and I'll set this to 2.8, which actually gives you just 25% of the light through the aperture of the camera. And to compensate for this, I'll also set the shutter speed to 1/25 of a second, which means I'll have 4 times as much motion blur, and I'll also have less depth of field. And I can render this. And as you can see, the shade map is still used, and this also rendered in 8 seconds. I can go the other way. I can set it down to F1 and then put my shutter speed up to 200 to compensate for that, to get more depth of field and less motion blur. And this still rendered in only 9 seconds. So you can see how the shade map is a very useful tool, both for speeding up stereoscopic workflows, since you don't have to render the left and right image separately. It can also be used to speed up single frame work, where you need to experiment with finding the correct camera parameters. Of course, there are some limitations. If you change your focus distance, I'll move it forward to the front horse. Actually, I'll minimize this so you see what's happening here. Since the VRay physical camera emulates a proper physical camera, the field of view actually changes slightly when you change the focus distance. So if I render this and bring up the frame buffer, you can see that mostly this looks good, but because of the changed field of view, you do get some artifacts where parts of the original rendered image doesn't quite line up. So if your focus hasn't been set, this won't be such a good advantage for working with single frames. But other than that, the shade maps are a great tool for speeding up a lot of blurry effects, and it also works with animation. It will actually save the shade maps. Let me show you how. With the file, the frame number. So you can render out the shade map for your entire animation and then go back and render it as a stereoscopic animation, or changing your camera f-stops and shutter speeds and things like that after the shade map generation. So it allows for more experimentation and in a shorter time frame. In VRay 2.0, there's a new stereoscopic rig system that lets you use already existing stereoscopic cameras for rendering stereoscopic images. There are many cases when you want to use existing cameras instead of having the VRay stereoscopic helper creating a left and right view based on a central camera. For instance, if you're getting the cameras from another application through an FBX import, or if you have camera tracked or match moved cameras from live action stereoscopic footage, then you want to make sure that you're using the exact camera that has been imported. And in this scene, I have two cameras, a left and a right camera. And you can see the views from the two cameras down here. These are this is the left camera and the right camera, and you see how the view is slightly different. Now, the way to tell the VRay stereoscopic helper to use the existing left and right cameras is to go to the Create tab, to Systems, and then select VRay, and create a new VRay stereo rig. And you can now drag this out anywhere, doesn't matter where, because we'll be assigning these cameras to this rig later. And the way we do this is we go to the Motion tab, and then there's a controller here for the VRay stereo rig, and we pick the left camera and we pick the right camera and select replace. Now if I go here, I can select my new camera 1, which was created by the VRay stereoscopic rig, and this is now centered between my left and right cameras, which indicates that these are the two cameras that are being used. So now I'll select my VRay stereoscopic helper and I'll render this. And you can see that the views, they are different. Even though my eye distance is set to 0, I could set this to 20 centimeters if I want to, and the rendering would come out exactly the same, because it's now using the existing cameras in the scene. And this is a really great way to use stereoscopic rendering in VRay in even more ways than we could earlier, because we can now work directly with match moved cameras, and we can work with cameras from other applications. For this section, I'll be talking about the new lens distortion options in VRay 2.0. And just to start, I'll render this frame without any distortion. Previously in VRay 1.5, you had a few options to create lens distortion in the physical VRay camera. I'll just save this to my history. You had the quadratic and the cubic option. Now in 2.0 you can use a lens file or a texture to create the distortion. Previously, when you wanted to match a physical camera lens, you basically had to go in and play with the quadratic or cubic distortion amounts to find something that matched your physical lens. But this was a matter of a lot of trial and error, and you wouldn't get a perfect match. And one of the reasons why you wouldn't get a perfect match is because lenses don't really have a perfect distortion like the cubic or quadratic distortions. There are usually slight variations in this distortion within the lens, and also every physical lens is unique. There might be slight variations between the exact same lens from the same manufacturer, just because of the precision in the production process. So the way you can get an exact lens profile in VRay 2.0 is to use the new lens analysis tool, and you'll find this in the Chaos Group menu under Tools in the Start menu. And the way this works is, first you need to print a test chart, and for my sample here I've been shooting on a Canon 550D, which is the same as a T2i, in 16:9. So I choose 16:9 here, and then this will generate a PostScript file, and I have Acrobat Distiller installed, so this will just automatically just create this PDF file. I'll put this to full screen, and you can either print this out, but it also works pretty well just shooting it straight off your monitor with your lens and your camera. So that's what I've done in this sample, and I'll load this photo into the into the lens analysis tool, I'll add photos, and this is the photo I shot. And since this is from a video, I don't get any focal length information, so I'll just enter this. This is from an 18mm lens, and I'll analyze this. Okay, it says OK, quality perfect, and then I can go in and test the correction. So this is my corrected frame, and this is the original image that I shot. I can now go in and I can save this profile. I'll call this Canon 18mm video, and I'll save this. And then I can go back into 3ds Max and choose a lens file for my camera, and then I'll load this profile. And now when I render, this will match my my physical camera lens exactly. Of course, you have to make sure that you go in and you set up your physical camera the same way as the original lens. So I've set the focal length to 18mm, and I also have input the zoom factor for the 550D, which is 1.6. And you can find the zoom factor for your cameras online. Just do a Google search for your camera type and crop factor, and you'll find the correct figure to input here. Normally, Canon cameras have 1.6, Nikon have 1.5, unless you're shooting on a really high-end camera like 5D or other full-format sensor cameras which have a zoom factor of 1. There's no zoom factor in them at all. I'll just save this and load this into A, and I'll load this into B, and you can see how the camera distortion has been applied to my image. And this is really great if you want to match your image exactly to some background plate that you've shot on a camera. Now, what if you don't have the Acrobat Distiller installed? How do you get this PDF and how do you print it? Well, there's a website called PS2PDF where you can actually just convert your PostScript file generated by the lens analysis tool to a PDF, and then you can print this out or just shoot the calibration image off the screen. Okay, next we'll be looking at how we can convert a series of images through the lens analysis tool. Under correction here, you have something called correct and distort images. So I have a file sequence that I shot with my camera, and you can see some very apparent distortion going on around the edges here. These straight lines are being curved, and when you want to take this image or this image sequence into something like SynthEyes or a PF-Track to track this into a 3D camera, you don't really want this distortion. Now, most camera tracking software does have lens correction tools built in, but these normally apply a uniform distortion and doesn't take small variations into account like the profile from the lens analysis tool will do. So I'll just go back in here and I'll add this. I'll add my directory actually, and I'll select undistort using this profile that I created. This runs through all the images and processes them, and I'll place this into a separate folder called corrected, I'll go back into PD Player and I'll load this new sequence. You can see the curved lines we had here, they've now been straightened, and this is a great starting point for taking this sequence into some sort of camera tracking application and getting the correct camera track. If you look at the difference between these, you see there's been quite a big shift, and you can also see these rings that are from where the distortion changes the image. Now, if you have a zoom lens is a bit different because the distortion will actually vary according to the focal length of the lens. So in order to create a profile for a zoom lens, you have to take a series of photos throughout the range of the lens. So I'll just add these photos here, and you can see this one is for a 26mm focal length up to a 63mm focal length, and I have a few images from a couple of the different focal lengths. So I'll just go in and analyze this, and they come in with good quality. And now I'll go and select Consolidate Profile. What this does is it takes the best results from each of the focal lengths and applies that to the profile. So now I've created a calibration profile for my zoom lens, and I can go in and save this. And I can go into Max and I can apply this zoom lens profile to my lens. And now I'll get the correct distortion from my physical lens depending on the focal length. So if you have something like a zoom shot, your VRay rendering will be distorted correctly throughout the length or the range of the lens. Okay, so that concludes the VRay lens analysis section. In this section I'll be talking about the new VRay exposure control in VRay 2.0. So I've set up this simple scene with a VRay sun and a VRay sky, and let's just render this through my VRay physical camera first. And I've set up my aperture to f11, and I have my shutter speed to 100th of a second, and the ISO is 100. So this is a pretty good exposure for this scene because I've used the exposure controls in the VRay camera. Now sometimes you need to render your scene through an orthographic view or a standard camera or even just a perspective view for some various reasons, and I've set up a standard camera at the exact same location as my VRay camera. So let's try to render this and see what happens. And immediately you'll notice that because the standard cameras doesn't have the same kind of exposure control that the VRay physical camera has, this is just blown out into complete white. I had to pull the exposure 5 stops down just to be able to get something close to the original image. So in VRay 2.0, if I just press 8 to bring up my environments and effects dialog, there's a new VRay exposure control, and with this you can go in and you can either use the photographic controls. You can get your exposure from an existing VRay camera in your scene, or you can just use an exposure value parameter to adjust the exposure. So first let's just go in and just adjust my shutter speed to 100, which is what I had in my VRay physical camera, and I'll set my f-stop to 11, and let's render this. You can instantly see that this is a much better exposure. Now we can also go in and get the parameters from the VRay camera. I'll press H to bring up my pick object dialog, and I'll pick my VRay physical camera. And now let's render this again. And you can see it gives me the exact same exposure I had in the VRay camera. And this is really good because now I can go in to a perspective view, or even just a front view, and get this rendered with the correct exposure without it being blown out. The last control is the EV parameter, where you can just adjust the exposure value to something that will give you the correct exposure. Higher numbers makes the image darker, lower numbers makes the image brighter. So okay, so that's the new VRay exposure control in VRay 2.0. In VRay 2.0 there's a new parameter in the light cache called the retrace threshold, and this can be used to improve the quality of glossy reflections and refractions that are being rendered using the light cache. So in this scene I have a glass box and a mirror, and I have a light source off to the right in the back here casting shadows on the floor in front. And first I'll just go ahead and render this without any light cache options for the glossies. And so this is just the brute force glossy reflections and refractions. And as you can see, the unsharp reflections and the unsharp refractions, they render correctly now, because of course I'm not using any light cache trick to store these. So I'll go in and I'll just save this to my history, and then I'll enable use light cache for glossy rays, and I'll render again. And this is the result you'd get in 1.5. Of course you could turn on filtering to improve the result somewhat, but you'd still get this incorrect blurry interpolation between the different samples of the light cache. You can see some artifacts here as well, where it's the unsharp reflections just picking up the light cache samples. So I'll save this, and you can clearly see the incorrect result. So in VRay 2.0 this has been improved by this parameter called the retrace threshold, and what this parameter does is it looks at the distance from the surface to the reflection or refraction, and also the glossiness value of that surface. And based on this threshold, it determines whether it should trace these rays again or use the light cache samples. So now that we've enabled this, let's take a look at what this does to our rendering. You can see now that the unsharp refractions and also the unsharp reflections, they now render correctly. And we still got some speed up. The original, without any light cache for glossy rays, used 29 or took 29 seconds to render. Then when we enabled the use light cache for glossy rays, it took 20 seconds, so we saved 9 seconds. And then by enabling the retrace threshold to actually get a usable result, it took 24 seconds, so we still save about 5 seconds per frame by using this technique. And now we have an image where you can still see some slight difference up here, but that's not really a very significant difference at all. You'll get away with this slight difference, but in the area where it matters, you get the correct result. Now, if you find you're still getting some artifacts, you can adjust the retrace threshold value. So, just to demonstrate, I'll lower this to 0.5. And as you can see, this value might be a bit too low, because you start to see some artifacts in this area. But we did save another second of the rendering time. And then again, if you're seeing artifacts still with the default value of 1, you can increase this to something higher to get rid of those. This is a very good technique to speed up your rendering if you have a lot of unsharp reflections and refractions in your scene. Another good use for the retrace threshold is to clean up light leaks in your secondary GI solution. In this scene, I have this thin wall with some trim and a very bright light source on the outside. So this is my camera view, and when I render this, you'll quickly notice that we get some really ugly light leaks that are that's light leaking from the light cache samples on the outside of this thin wall. Now we can use the retrace threshold to get rid of these as well. So this is just a matter of enabling the retrace threshold, and just like in the sample with the glossy reflections and refractions, VRay will retrace the needed areas based on their distance from the samples. And you'll also notice that the render time will increase because VRay has to trace more rays in these areas where we previously had the light leaks. But as you can see, it now clears that up very nicely, and it's still able to use all the light cache samples for the rest of the scene where we didn't have any light leaks. Of course, now I'm rendering this with slightly low sample settings because of I didn't want to spend too much time on watching the rendering happen, but you can see it's a big improvement compared to the previous result. So this is basically a one checkbox fix for most of your light leak problems from the light cache. VRay 2.0 has a new global illumination method called bidirectional path tracing, and this is an unbiased method that traces rays both from the light sources in your scene as well as from the camera, and then combines these rays to come up with a lighting solution for tricky situations very quickly. Now, the way you add this to your scene is you go to helpers, VRay, and then you create VRay bidirectional path tracer helper. You can just add it anywhere in your scene, and as you can see, this is still in development. It's been included in VRay 2.0, but I'm expecting this to be developed a lot further in service packs. You can tell by this rollout called debug don't touch that this isn't considered done yet, and that's also probably why it's not in the render setup dialog from the drop downs for indirect illumination methods. So once you've added this helper to your scene, this will override any GI settings you've set up in the render setup dialog over here. It doesn't matter if you have brute force or light cache or whatever selected, it will always render using bidirectional path tracing, and you can turn it off again and on again with this checkbox. Right now there's only one algorithm available for selection, and then only a few parameters so far. You have the number of passes, and this is, you'll see in a short while how it works when rendering. This is the number of passes it will render, and then how many light bounces. You can also choose to enable reflective caustics or refractive caustics. So now I've added this to my scene, so I'll just render this Cornell box really quickly, and you can see how the bidirectional path tracer just renders passes, that each pass just refines the solution. And you also see some caustics here and also on the wall, which are most likely reflected off this chrome sphere through this other glass sphere and hits the wall. So it produces a very accurate, unbiased lighting solution, but it is kind of slow, so it will take quite a while to clear up all the noise. So I'm just gonna cancel this rendering. It'll just continue working through the 100 passes and refining the solution and clearing up the noise. You see these little dots here. These will also clear up eventually if you have enough passes set up, and eventually you'll have a very smooth, unbiased, very accurate lighting solution from your scene. Okay, so I'll cancel this, and let's take a look at an example of a scene where the bidirectional path tracer can be very useful. I'll just hide these objects and turn on these objects. And what I've done here is the only light in the scene is a planar VRay light sitting inside this box, which has a hole in the top up here, and it's just directed towards the ceiling, so all the light in the scene is bounced off the ceiling and into this Cornell box. So let's go and turn off the bidirectional path tracing and see how this renders using light cache with brute force. I'll just go ahead and render this. I'll pause the recording while rendering this frame. Okay, so the frame has finished rendering, and you can see it took 2 minutes and 51 seconds. And the light cache was able to get the light into the Cornell box, but the problem with using light cache for this is that you can tell that there's not a lot of detail in the shadow areas here, and also in the corners there's not as much detail as we'd like. So I'll go ahead and save this for reference, and we can try rendering this with brute force for both primary and secondary bounces. And to get enough light into this scene, I've selected 16 secondary bounces, and I've also lowered the noise threshold for the DMC sampler. I'm using adaptive DMC here with max subdivisions set to 100. So let's go ahead and render this. And the first thing you'll notice is that this is going to take a long time, and you'll also notice that there's some still a lot of noise in the shadow areas. Once these buckets get done, we can see if we get any more detail in this area. And the reason this is taking so long is that using the brute force method, we're just shooting almost randomly into the scene and bouncing around and trying to find this light source hidden in this box below the ceiling. And it's not a very efficient way to do it. Okay, so you can see now we're getting slightly more detail here now, but it's the estimated time for this rendering is already getting close to 37, 38, 39 minutes. We can also look at this shadow below the sphere and see if we can get some more detail here. I'll pause the recording for a little while and let this image render a bit further. Okay, so we've rendered a bit more of these buckets here, and you can see there's more detail, but there's also more noise. So we'd have to go in and use even higher settings for our brute force rendering to clear this up, and that would increase the render time even more. So now I'm just going to cancel this brute force rendering, and I'm going to save this for reference as well. We can go compare the two. You can tell there's more definition in the shadow below the sphere here, and there's also more definition in the corners, but there's still way too much noise for this to be useful in production. And I'm only rendering this at 320 by 320, so for any production sized images this is just almost useless. So now we're going to go back to the VRay bidirectional path tracer, and we're going to enable this, and we'll render this with bidirectional path tracing. I'll set the number of passes to 200 and 16 bounces, since that's the same as I had in my brute force, and we'll render this. You can see the bidirectional path tracer starts working through the passes and refining the detail, and you can tell that we're already seeing more shadow definition down here below the sphere and also in the corners, even though this is only rendered for 25 seconds. And that's because the bidirectional path tracer is actually shooting the rays out from the light into the scene as well as from the camera. So instead of the camera rays having to search for randomly searching for the hidden light, the light is actually helping in the process itself. So I'm going to pause this and resume the recording when the image has rendered with the 200 passes. Okay, so the image finished rendering with bidirectional path tracing, and it took a little over 6 minutes. So I'll just save this as well, and I'll load the light cache into A and the bidirectional image into B. And as you can see, there's still some noise in the bidirectional path tracing, but if you look at the amount of detail we're getting in the shadow areas, it's a lot better with the bidirectional path tracing, especially under the sphere and also in the corners of the room. And this is a very accurate lighting solution because it's an unbiased solution. And the only other way to get something that approaches this accuracy would have been to use I'll just put the brute force image into channel A here. Would have been to use brute force, but as you can see, this at an estimated render time of over 40 minutes is still a lot worse than the bidirectional path tracing when it comes to the amount of noise, and also the detail is already better here in the bidirectional path tracing. So, as I said, currently this is implemented as a helper in VRay, and this is the first version of the bidirectional path tracer. So I'm sure that as the development of this progresses, it'll be a very useful new GI method for extremely tricky situations like this one, where we only have the indirect light. So that's the bidirectional path tracer. The VRay Proxy has received a few improvements in VRay 2.0. The first improvement is that the proxies now render faster than they did in VRay 1.5. Then the second and probably more interesting improvement is that when you export a mesh to a VRay proxy, you can now choose to also export a point cloud with varying levels of detail in the same VRay proxy. And then at render time, VRay will be able to use this point cloud if the object is far away, and it will substitute each point in this point cloud with a disk, a flat disk. And if you're far enough away, this will actually give the exact same look as the object when rendered as a mesh. So this is a way of speeding up proxy rendering even more, and also using less memory and faster load time of the proxies. So let's take a look at how we can set this up. I have a deer object, and it contains a little over 1.5 million polygons. So let's just go in and convert this to a VRay proxy. Now you'll see the new option here to export the point clouds. So when you enable this, you also have a parameter called lowest level point size, and the default value is 2.0. If you increase this, this will also increase the size of the disks used and reduce the number of points in the point cloud. I would recommend leaving this to the default value, because higher values will lead to some artifacts if you're getting closer to the object. So by leaving this to the default value, that ensures that you have enough detail in your point clouds. So let's just go ahead and convert this to a proxy. This will just take a short while. Okay, so now we have our proxy here. It's been written to the disk, and let's look at the new parameters here in the mesh proxy. You have a new spinner here called point cloud. So let's just set this to 1 and render our object. Like the level multiplier, it controls the proxy rendering at the different distances, and the default value of 1 is usually the best option, because this means that when you're getting close to the object, you will render using the original mesh, but as you move further away, it'll change the mesh into the point cloud and start rendering using the disks instead. You can set this to 0 to enable always using the mesh part of the proxy, or you can increase it to force it to use the point cloud when you're getting closer. So if I set this to 50 and render, you'll notice I get these very exaggerated disks around a very few points that I have in my model. So when you're getting this close, you wouldn't really want to use such high values. But as you move the object back in the scene, if the value is set to 1, if it gets really far back, then VRay will automatically just use a few points in the point cloud and apply the disks, and it will shade it so it looks like the proper object. And then as it gets closer, the point cloud will be denser and denser, and you'll get more disks to represent your object. So that's the point clouds in the VRay proxy. One of the big changes in VRay 2.0 is that VRay RT is now part of the standard VRay package. Most of you know RT, of course. VRay RT is an interactive renderer that will continuously update a rendering of your scene while you are working on it, and it's a great tool for interactive lighting and material work, and it can even be used for production rendering. So I've set up this scene to show some of the new features of VRay RT 2.0, which is part of VRay 2.0. And I'll start by opening my render dialog, and I've assigned VRay RT down here as the active shade render. And I've also enabled proxy objects and particle systems, which are some of the new features now. So I'll start an active shade render. VRay translates the scene to a VR scene format and sends it to VRay RT. And the first thing you notice is that particle systems are now supported directly in VRay RT. In previous versions you had to put a measure modifier on your particle systems in order to see them in VRay RT. Now you can just check this box and you'll see them instantly. The next thing I'd like to mention is actually the alpha channel. Previous versions of VRay RT didn't actually have an alpha channel, and VRay RT 2.0 has a proper alpha channel now, so you can use VRay RT renderings for compositing easier than you could before. Then you'll notice that this glass material has dispersion. VRay RT supports the new dispersion material in VRay 2.0, so it's easy now to interactively see your results as you adjust the AB value here to create the glass look you want in your materials. Now the next thing is that this deer here is a VRay proxy, and VRay RT now supports rendering of VRay proxies. Previously you just you wouldn't get anything in the RT rendering, and this is also a big advantage, that you now have big scenes with proxies and they will show up in the RT render. Over here you'll notice that we now have displacement support in VRay RT. If you look at the viewport, there's no displacement here, but the displacement shows up in VRay RT. This is a limited displacement implementation, though. It actually takes the displacement map from the material, and if I select this object, you'll notice that I don't have a VRay displacement modifier on this. It won't actually make any difference if I add a VRay displacement modifier. If I change the amount of the displacement, see, nothing changes. So what it's actually doing is taking my mesh, and it's displacing it using the material settings, much like the material preview does. So to get a smooth displacement, I add a turbo smooth with quite a few iterations on it. You can see if I lower this, the displacement gets rougher. because there are fewer polygons to work with here. So but this is a step in the right direction, of course, and it's better than just having no displacement at all showing up in the viewport. Next thing I'd like to mention is the dim distance parameter of the reflection. This is now supported by VRay RT. Unfortunately, the fall off parameter isn't supported, so you won't get that smooth fade I showed you in the previous example when we covered the materials. But you can still change the distance so you get a better idea of where the reflection will stop if we're using this for a preview render while doing material work. You also notice that both these particles and the deer proxy here are using the new VRay car paint material, which is fully supported in VRay RT CPU. So this is also a great tool for setting up the exact car paint look that you want to create. It's very easy when you get this quick feedback from Material Editor. You can see it instantly on your object. The next thing I'd like to show you is that this is being rendered through a VRay physical camera. So if this was a perspective view and I started my my VRay RT render in the previous version, you'd get the same exposure problem that you get with regular max cameras and max viewports in earlier versions. The good news is that you can go in and add the VRay exposure control, and I can just pick my VRay physical camera and then start my active shade render again from the perspective view, and now the exposure is correct, so now I can just move around any way I want and I'll get the correct exposure. Of course, this scene is set up with a VRay sun, so it blows out if you're not correcting for exposure at all. Okay, so let's open the VRay RT render setup dialog again and take a look at this new parameter here, max paths per pixel. This is a way you can tell VRay RT to stop rendering after a certain number of paths per pixel has been reached. So if you put in 20 and render, you can see in the statistics readout here, which you can actually turn on and off over there. RT will start rendering, and then once it's reached 20 paths per pixel, it will stop rendering after, in this case, 12.4 seconds. So if you're rendering multiple frames, this is one way you can determine when this should move on to the next frame. You can also determine this by setting the maximum render time per frame, or you can of course use the noise threshold. So if you set this to 0, it will just keep going. Same for the time. If you set it to 0, it will just keep going. Now the noise threshold also has this mask here, which show the areas in red are the areas that have noise that's above the threshold, and those are the areas that are being rendered. The areas without the red, they're done basically, so no calculations are going on in those areas. And this is a good way, if you're rendering an animation in VRay RT, you can ensure that every frame will have the same noise level, so the noise level doesn't flicker. The last thing I want to show you is the stereoscopic vision, or the stereo vision here. In the previous version of VRay RT, you had these interlaced, checkered, and the anaglyph options. So if you're rendering, you get the old red cyan look. If you have 3D glasses, you can put them on now to see this in 3D. It's not really important for this demonstration though. The new feature in VRay RT 2.0 is that you can now use OpenGL stereo. However, this does require a Quadro card to work because it needs quad buffering. And if you enable this and you have a Quadro card, you'll be able to see the VRay RT buffer with your shutter glasses in full color stereo. Okay, so let's move on to VRay RT GPU. This is a new addition to VRay RT, and you just switch between the engines here. If you set it to OpenCL, VRay RT will actually use your GPU on your graphics card to do the interactive rendering. I'll turn off the OpenGL stereo as well. The VRay features supported by VRay RT GPU is a subset of the subsets supported by VRay RT. So even fewer of the features of the main VRay renderer are supported in VRay RT GPU. However, the big advantage is that it's very fast. So just to show you what works and what doesn't work, I'll start rendering this. The first thing you notice is that the car paint material renders as solid red, because the car paint material and also the VRay blend material isn't supported by the OpenCL single kernel engine. That means you can't use the GPU engine to work on your car paint materials. And the second thing you'll notice is that the dispersion in the glass material has been turned off. You can see if I open the material editor and go to the glass and I set this to a really exaggerated Abbey value, it still renders the same. There's no dispersion going on in here. Likewise, the dim distance parameter in the reflective mirror here is not working in VRay RT GPU. However, the displacement works. So you can see there's a lot less material-wise supported for now. This will surely improve over time. But the big advantage of using this engine is the speed. So to compare the speed between the CPU and GPU versions of VRay RT, I've loaded in a different scene. Now, because VRay GPU doesn't support the VRay car paint material, I've replaced it with a regular VRay material in this scene. And let's first select GPU engine and render this image. And you can see here that VRay RT is able to render about 520,000 K paths per second on this. This is an i7 920 at 2.64 gigahertz. And it's fairly quick. If I just move this around, I can it clears up pretty quickly. Takes a few seconds to get rid of the noise. So let's make a note of this, about 550, 520, around that range. So let's close this and switch to the GPU engine. You'll notice how fast this clears up the noise, and also the K-path number is almost 6 times as high as with the CPU. And this is running on a GeForce GTX 470, so it's not even the top of the range cards like 480 or even the 580 cards, or even the Quadro 4 and 5000 cards, which should be able to render this a lot faster. And also, if you have multiple GPUs in your system, VRay RT GPU will be able to use all of them at the same time. So you can, for instance, you can set up a system with 3 GeForce 480 cards and get something like 4 times this value. As you can see, when I rotate this around, as soon as I let go, it clears up almost instantly. There's a little bit of caustics that will take a little while to clear up, but other than that, the image looks really good right away. So that's the big advantage of using VRay RT GPU. In addition to the limitations we've discussed about the supported materials and other VRay features that are unsupported in VRay GPU, you also need to consider the amount of memory on your GPU card when you're rendering with VRay GPU. Basically, your entire scene needs to fit on the memory of your board. And if you have more than one board, the entire scene and all the textures needs to fit on each board. So one of the things that VRay RT GPU does is it actually resamples your textures down to a size you can adjust here before rendering. And this is a way to make sure you don't run out of memory on your GPU card, because if you run out of memory, you won't be able to render your scene. However, one really nice feature is that the frame buffer itself doesn't need to fit on the GPU memory. So with VRay RT GPU, you can go in and say something like you want to render this car in 4K and start the active shade. And VRay RT GPU renders this with no problems at all. You can see it's still performing at 3700 K paths, and we're rendering at 4000 pixels wide here, and it's actually clearing up pretty quickly. I can zoom back out, make this a little smaller so we can of course at 4K it's not as instant as when you're rendering at lower resolutions, but it's still very quick. And this is very good if you want to go in and check on small details. You know, you have an animation where you're going to get really close to certain details, and you can just start VRay RT GPU on a really high-res rendering, and you can just move around and zoom into the areas you want. And if you have a fast enough GPU, it clears the noise fairly quickly, so you can go in and examine the exact details that you want. Another new and very useful feature of VRay RT and VRay RT GPU in VRay 2.0 is that you can now actually go in and assign VRay RT as your production renderer. And when you do this, you'll notice that you have the normal VRay RT rollout here on the top, and then all the different VRay settings rollouts just continue on down in the render setup dialog. So you can go in and set everything for the normal VRay that will control RT, and you also have the VRay RT settings here on top. And of course you can use this to render final animations and final images, but I like to use this for a really quick preview render, and it's almost so fast that you can use it instead of the old grab viewport, create animated sequence type of preview, where you just grab the viewport and as an image sequence, and you could send this out to clients for animation approval, etc. So let's just look at this in VRay RT with active shade on, and you see as I scrub through, if I pause for just a few seconds, VRay RT GPU is able to completely clear up the resolution and a lot of the noise. In just 2 or 3 seconds, you get a very usable image that shows off your reflections and shadows and all the lighting in your scene. And this is a much better preview than a regular viewport grab, and much better for sending to a client who maybe doesn't understand the wireframes or just Phong shaded geometry. And it also lets you send one preview file, or it lets you view one preview file instead of just creating a wireframe or a smooth shaded preview and then rendering a few still frames in addition to this. So I'll close this and I'll go back to my production renderer, and I'll go in here and I want to render these frames. I want to render my active time segment at this. I'll lower the resolution slightly, 640 by 360, since this is just a preview, almost like a play blast. And I'll go in and save this as an OpenEXR sequence. GPU car. Save this as a half float format. And then I'll go in here and I'll tell VRay RT GPU, I'll select the GPU, and then I'll tell VRay RT GPU to only spend about 0.05 minutes, which is 3 seconds per frame. And then I'll go ahead and render this. You can see now every image is quite usable, and VRay RT GPU only spends about 3 seconds per frame, and my entire preview will be rendered in 5 minutes. You can set this time limit even lower if you want. If you're in a rush, if you need something in just a few minutes, just 2 minutes or something, you set it to 1 second, and you get a very quick preview of the entire lighting through your animation. So I'll just pause the recording while this is rendering, and then we'll look at the final animation. Okay, so the animation is almost rendered. Entire 101 frame sequence has rendered in 5.5 minutes. You'll notice that this says unsupported GI is disabled. That's because I have the warn for unsupported features checked. If you uncheck this, you won't get these in your frames. So now let's move into PD Player, and we'll just load this sequence. I'll ignore the alpha channel, and I'll preload it into the cache. Now we can play the animation, and this is much nicer than one of the old 3ds Max viewport previews. And also, since this is an EXR format, I can go in and adjust the exposure, the contrast, whatever, create some add some color corrections before I generate a preview that I send to the client to approve the animation and the lighting. So this took just a little over 5 minutes to render out on my graphics card. So it's a really big speed up in production work when you're able to create these kinds of previews for clients, or for internal supervisors, or just for your own tests this quickly. So this was the end of the VRay RT GPU video, and also the end of the VRay 2.0 new features training videos.